Today we're going to look at Unit 6 Logarithms Lesson 4, which is the first half of Section 8.5, exponential and logarithmic equations. Today we're going to look at exponential equations. So the homework assignment attached to that is on page 472, the 5 through 11 odd, 25 and 27. So this is for part 1, and then the next half of the lesson is with part 2. So that'll be with the log equations. So today we're focusing again on the exponential equation. So the assignment that goes along with that is this, and then on the next lesson, the next half of the lesson, logarithmic equations, the assignment that goes along with that is highlighted in blue. So an exponential equation is an equation ultimately where the exponent includes the variable. So the big idea is that our variable is in the exponent, and that's why it's called an exponential equation. One strategy that we're going to use today is taking a common log on both sides. So if m and n are both positive numbers and we know that m equals n, so meaning if I have some kind of equality statement, then what I can do is I can take the log of both sides, and log of m is equivalent to log of n. And so the first method that we're going to use corresponds to using that strategy. So we're going to today, in example 1, isolate the base and the exponent. So if we look at example 1a, the base and the exponent are already isolated, right? The only thing I have on one side is the b raised to the cx power. In this case, it's the 2 to the 3x minus 4 power. I want that completely by itself. In b, we have more work to do because it's that 3 to the 2x that we want to be isolated. Okay, so our work starts with, we want to get this piece by itself. And so that would just be doing regular inverse operations like adding, subtracting, multiplying, dividing. Once we have that, we're going to take the common log of both sides and use our calculators to get our answers. And so when I have my base and my exponent isolated, like I do in example 1a, I'm going to take the common log of both sides, meaning I'm going to have log of my left-hand side equal to log of my right-hand side. And so remember that we can perform any kind of operation on a math problem in an equation as long as we do it to both sides of the equation. And so we have log of 2 to the 3x minus 4 power equals log of 5. The reason that we're going to take a log is because a log allows us to move the exponent. Okay, so the big idea here is I want x to not be in a power anymore. And so this gives me the opportunity to move that x into the front of the log, or our entire exponent. So we've got 3x minus 4, which was our exponent, and that equals, that is times now just log of 2 equal to just log of 5. So we took the log of both sides so that we can move the exponent to the front of our log. Now that that variable is a regular number, not a power anymore, we can start to solve for it. So the first thing that we want to do is, again, our goal here is to isolate x. So to get x by itself, we want to first get rid of the log rather than, say, distribute it. So we're going to take and divide both sides by log of 2. And so now on the left-hand side, we have 3x minus 4 equals log of 5 divided by log of 2. Oh, I was writing kind of large. So what we can do here is we can estimate that log of 5 divided by log of 2 by plugging it into our calculator. So if we look at our calculators, we should have a button that just says log, right? That's our common log, our base 10 log. So we are going to type into our calculator log 5, and then you should need to close a parenthesis. Make sure that you have log 5 in parentheses like this within your calculator, or it's going to do something wrong. Divided by, same thing with the log, should give you a parenthesis to close the parenthesis, okay? And so my calculator gives me 3.219 for this value. So this is about 2.3219. And so now I want to get my x by itself. So I've got 3x minus 4 is about, I'm just going to rewrite this as a single line, 2.3219. So to get the x by itself, I want to add the 4. So I now have 3x is about 6.3219. And then I want to divide both sides by 3. And so that's going to give me that x is about 6.3219 divided by 3 is about 2.1073. Okay, so we isolated the base and exponent. Actually, we didn't have to. It was done for us. And then we took the common log of both sides. We used the power property to move our power to the front of the log. Okay, so in this step, we used our power property. Move our exponent so that we could then solve for x. Okay, so this one's going to be a little bit longer. So I'll write a little bit smaller than I did in that one so that we can have some space. So big idea, again, we want to get that purple thing by itself. And so since it's 5 minus 3 to the 2x power, so the 3 to the 2x power is the thing that we want by itself. We even want to get rid of the minus, equals negative 40. So let's start by subtracting the 5 from both sides, so that it cancels out. So we've got negative 3 to the 2x power equals negative 45. And so we don't want that negative there. We want it to just be the 3 to the 2x power. So we want that piece alone. So to get rid of the negative, we're going to divide both sides by negative 1. So we have positive 3 to the 2x power equals positive 45. So dividing by 1 just changes both of those signs. So remember that our big idea here is we now want to take the common log of both sides. So we're going to take log of our 3 to the 2x power equals log of our 45. Okay, so log of 3 to the 2x equals log of 45. So once we have log on both sides, that's when we're going to use our power property. So we're going to take our power, which was 2 times x, and we're going to move it to the front of that log. So we're going to have 2x times log of 3 equals log of 45. And I'm just going to leave it in the parentheses so that we remember to use those in our calculator. Okay, so I want x by itself. Right now, x is being multiplied actually by 2 things. And so what we can do here is we can actually divide by both of those things so that we can cancel them out and just have x on the left. And so it's being multiplied by the 2, so we want to divide by 2. It's also being multiplied by log of 3, so we want to divide by both of those. Okay, so we're going to divide by 2 times log of 3. So that the 2 cancels and the log of 3 cancels. And so we have x equals log of 45 divided by 2 times log of 3. And so if your calculator doesn't give you like the visual of a fraction, you're gonna need to put parentheses around the 2 times log of 3 in order to get the correct answer. Okay, so when you type this into your calculator, if you have that button where it makes a fraction and you can plug into the numerator and the denominator, those kind of turquoise colored, I guess that's teal colored parentheses aren't necessary. So we're going to type in log of 45, don't forget to close your parentheses, divided by, and depending on our calculator, we're either going to put parentheses around that or make a fraction, 2 times log of 3, and then close 2 parentheses or 1, kind of depending. And then for this answer, we should get about 1.732, and then it's for 8, so that's going to round up to a 5. Okay, so 1.7325 for that solution. Okay, so that was one method. What you'll notice is that, for example, 3, I actually gave us the exact same problems. So we could see what happens when we change the method and kind of make a decision for ourselves which method we prefer. Okay, so in this method, we isolated the base and the exponent, and then we took the log of both sides. And really the big idea was to be able to use that power property to move our exponent to the front of that log on the left. And then we did some inverse operations to get x by itself. Okay. And so the second method involves something called the change of base formula. So the change of base formula is in that box on the right. So it tells us that if I have a log of any base, I can actually turn it into a log of any other base. Typically, I'm going to use base 10 to do this because then my calculator can do it. When we get into the section on natural logs, we can also use a natural log to do that, but we'll talk about that more when we get there. So ultimately, looking at what's happening within the change of base formula, you can take any log and turn it into a different log of any other base by turning it into a ratio. So this would mean that we would take log and over log, and we're going to do the common log, so we aren't going to add a base there so that we can use our calculator to get the answer. And so the first value on top is our quantity that we're taking the log of, which in this case is 40. And then the value on the bottom that we're taking log of now is the value of our original base. So we have log base 3 of 40, and then we're rewriting that as log of 40 divided by log of 3. Okay, so we're going to plug this in our calculator just like we've been doing in the previous problem. So remember, you might want to put parentheses around this on your paper so that you don't forget about that. So when we calculate log of 40 divided by log of 3, that should give you about 3.3578. Okay, so that should give you about 3.3578. Okay. This question is also asking us to take this value. Okay, so this is an answer, but they want us to take this value and convert it to a log with base 2. Okay, so what we want to do in order to convert to a log of base 2 is we're going to take 2 and we're going to raise it to the power of our answer, which was 3.3578. Okay, so we're raising it to that power. That gives us a value, if we put that in our calculator, so we're doing 2 raised to the power of 3.3578, and that should give you about 10.253 if you place that in your calculator. Okay. And so using this now, we can rewrite it as a log of base 2 by writing log base 2 of 10.253. Okay. So we took a log in base 3, we wrote it as a fraction of log base 10 to get a value. Okay, so that's how we can estimate it or in our calculator. And then whatever the base is that we want to rewrite it as, we take that number and raise it to that power, and that'll give us a new log. Okay, so let's try it one more time with log base 5 of 3. Okay, so when we write out our change of base formula, we're going to have log of something over log of something else. And so our 3 goes on top and the 5 goes on the bottom. So visually we can see that they're essentially, oops, I almost wrote a 2, in the same spots as they were in the original log, right? The 3's higher, it's on top, the 5's lower, it's on the bottom. So kind of use that to help you. So if I calculate this, log of 3 divided by log of 5, I get about 0.6826. Okay. And so this is our first answer, right? It's asking to use the change of base formula to evaluate. And then we want to convert it to something with a base of 2. So we're going to raise 2 to the power of our answer. So our answer was 0.6826. And if we calculate that in our calculator, so we're raising 2 to that power, we get about 1.6050. So the second half of our answer incorporates log base 2. So this log base 5 of 3 is this equivalent to log base 2 of 1.6050. Okay. So what the change of base formula does is that it allows us to use our regular calculator to evaluate logs that are not of base 10. So we're going to use the change of base formula to answer the questions for example 3 now. Okay, so the first part is the same. We still want to isolate our base and exponent first. So we want to get those pieces the same. So the beginning of this process is the same no matter which method we're doing. The change is we are then going to rewrite in log form and then use the change of base formula. Okay. And so instead of using the power properties and dividing out logs, getting a log on both sides, rewriting in log form and using the change of base formula is our new method. So in A, just like it was on the when we did it in example 1, we are already isolated. So it's 2 to the 3x plus 4 power. What we're going to do is we're going to switch it to log form. So remember that we look for our base. So our base is 2. So that means the log form of this is going to be log base 2. The way that I like to think about it is that the 5 and the 3x plus 4 essentially switch sides compared to the equal sign. So the 5 goes with the log and the 3x minus 4 goes over to the side where the log is not. Okay, so 2 to the 3x minus 4 equals 5 is equivalent to log base 2 of 5 equals 3x minus 4. Okay. And so what we want to do here is we want to use the change of base formula so that we can evaluate this log. Meaning we've got log of 5 over log of 2 equals that 3x minus 4. Okay, so we're going to evaluate log of 5. Sorry. That's a different color. That didn't work. Log of 5. Let's find our purple. There we go. Over log of 2 equals 3x minus 4. Okay, so if I calculate out log of 5 divided by log of 2, we should get 2.3219, and that equals 3x minus 4. And so to get x by itself, we just have to do inverse operations. So we're going to add 4. So 3x equals 6x. Wow, 6.3219. And then we're going to divide by 3. I guess I could just look up instead of dividing by this because it's the same numbers. So we get x equals 2.1073. Okay. So notice that if we look back up at our example 1, A, we got 2.1073. So our process is different, but our answer is the same. So to kind of recap what we did, we took and isolated our base and our exponent, but we were lucky and the problem was already set up the way it needed to be, so we didn't have to do anything in that step. Then we switched it to log form, and then we used our change of base formula on our log, And then we solved our problem because now we had a calculated value and we had some nice inverse operations. Okay. So let's go through that process one more time with B. So if we think about what we did in part B above, right, these first steps are going to be the same. So all of this part for both methods is the same. It's after that step that things change. Okay, so I'm going to go through those steps a little bit faster because it's the same process as we just did there. Okay, so we're going to subtract our 5 and then divide by our -1. So we're going to subtract 5 from both sides, which gives us -3 to the 2x power equals -45. Then we want that negative gone, so we're going to divide both sides by -1. Which is going to give us 3 to the 2x power equals +45. Okay. So that's our first step in the process, is isolating that guy. So we're done with that. Now we want to rewrite it in log form. Okay, so in log form, we look for the base. Our base is 3. Remember that essentially the 2x and the 45 just switch sides from the equal sign. So 3 to the 2x equals 45 is equivalent to log base 3 of 45 equal to 2x. So once we've done that, we're able to now use change of base. So we're going to change our log base 3 of 45 to log of 45 divided by log of 3. So we've got log of 45 divided by log of 3. And then that's still equal to 2x. So we are ready to calculate. So we're going to calculate log of 45 divided by, oh, whoops, sorry. Oh, no. Okay, sorry, I had technical difficulty. So we have log of 45 divided by log of 3. So we're going to calculate log 45 divided by log 3. And that gives us 3.4650. So we really get 3.46497, but that 7 is going to make that round up. So we're going to end up with 50 equals 2x. And so to get x by itself, we're going to divide both sides by 2. So that tells us that x should be the same as our previous problem. So 3.4650 divided by 2 gives us 1.7325. And so if we check 1.7325 is what we got in the first example. So remember that I'm giving you 2 different methods. I'm not dictating which method you should use. So you decide for yourself which method you prefer, and you study that one method. Okay? So you do kind of need to know what they each are in order to maybe do a problem where you're checking someone's error. But in terms of you being able to do your test the day of, just make sure that you have a method that you can solve and use the problems that are highlighted in yellow to practice.